Azure Simplified, a practical introduction to Microsoft's cloud platform. Chapter 1, The Cloud Unveiled. What is cloud computing and why Azure? Imagine a future where you never have to buy another computer server, worry about hard drive failures, or spend sleepless nights patching software. Imagine instead simply paying for the computing power, storage, and networking you need, exactly when you need it, and letting someone else handle all the heavy lifting. This future is not only here. It's thriving, and it's called cloud computing. For many years, running a business meant owning and maintaining rows of expensive, humming servers in a dedicated room, known as a data center. It meant meticulously planning for future growth, purchasing more powerful hardware than you might immediately need, and constantly battling issues like power outages, cooling demands, and security threats. This approach was costly, time-consuming, and often rigid. Then came the internet, followed by virtualization technology, which allowed a single physical server to run multiple virtual servers. These innovations paved the way for a revolutionary idea. What if computing resources could be accessed like any other utility, such as electricity or water? You don't build your own power plant. You simply plug into the grid and pay for what you consume. This simple yet profound shift is at the heart of cloud computing. 1.1 What is cloud computing? Breaking down the jargon. At its core, cloud computing is the on-demand delivery of computing services, such as servers, storage, databases, networking, software, analytics, and intelligence, over the internet, the famous cloud. Instead of owning and maintaining your own computing infrastructure, you can access these services from a cloud provider like Microsoft, paying only for what you use. Think of it like this, like electricity. You plug in your appliances, consume power, and pay for the kilowatt hours you use. You don't own the power station or maintain the transmission lines. Similarly, with cloud computing, you tap into a vast pool of computing power and pay for the processing, storage, and services you consume. Like renting versus owning. Instead of buying a house, building your own data center with all the associated costs and responsibilities, mortgage, maintenance, utilities, repairs, you rent an apartment, use cloud services. You get to use the space and amenities without the burden of ownership. This analogy helps explain some of the key characteristics of cloud computing: on-demand self-service. You can provision computing resources like virtual machines or storage almost instantly, without human interaction from the service provider. Need more storage for a spike in customer data? Click a button, and it's there. Broad network access. Services are available over the internet from virtually anywhere, on any device. Your team can work from the office, home, or halfway across the world. Resource pooling. The provider's computing resources are pooled to serve multiple customers in a multi-tenant model. This allows for efficiencies of scale. Rapid elasticity. Computing resources can be quickly and easily scaled up or down, automatically if needed, to meet fluctuating demand. If your website gets a sudden surge of visitors, the cloud can automatically add more servers to handle the load, then scale back down when the rush subsides. Measured service. Cloud usage is metered, meaning you pay only for what you consume. This transparency allows for better financial management and optimization. 1.2 The evolution from on-premises to cloud. To fully appreciate the cloud, it helps to understand where we came from. For decades, businesses operated IT infrastructure on-premises, meaning all their servers, networking equipment, and software were housed within their own physical buildings. This on-prem model came with significant challenges: high upfront costs, CapEx. Buying servers, storage arrays, networking gear, and specialized facilities requires massive initial investments. Maintenance and management, OpEx. Dedicated IT staff are needed to install, patch, maintain, and troubleshoot hardware and software. This includes physical security, power, cooling, and network connectivity. Scalability limitations. If business grows quickly, you need to buy and deploy new hardware, which can take weeks or months. If demand shrinks, you're stuck with expensive, underutilized equipment. Disaster recovery complexities. Protecting against data loss from floods, fires, or cyber attacks requires complex, expensive backup data centers and recovery plans. Underutilization. Often, servers sit idle for much of the time, leading to wasted resources and money. The cloud directly addresses these pain points. By shifting from capital expenditure, buying assets, to operational expenditure, paying for services as you use them, businesses gain financial flexibility. The cloud provider handles the infrastructure, freeing up organizations to focus on their core business rather than maintaining IT plumbing. 1.3 Cloud Service Models. IaaS, PaaS, and SaaS explained. One of the first things you'll encounter in the cloud world are the acronyms IaaS, PaaS, and SaaS. These describe the different levels of service you can rent from a cloud provider. Think of it as a spectrum of responsibility. Who handles what? Infrastructure as a service, IaaS. What it is? IaaS gives you the most basic building blocks of cloud computing. Virtual machines, VMS, networks, storage, and operating systems. You manage the operating system, applications, and data, while the cloud provider manages the underlying infrastructure, the physical servers, networking, virtualization. Analogy: imagine you're leasing a raw car chassis. You get the fundamental vehicle frame and engine, but you're responsible for choosing and installing the seats, steering wheel, entertainment system, and painting it. You have maximum control over the internal workings. Azure examples: Azure Virtual Machines. You get a virtual computer on which you can install any operating system, Windows, Linux, and applications you choose. Azure Virtual Networks. You create your own isolated network space in the cloud. Azure Storage. You provision raw storage space for your data. Platform as a Service, PaaS. What it is? PaaS provides a ready-to-use environment for developing, running, and managing applications. The cloud provider manages the underlying operating system, server software, and often the database, allowing you to focus purely on writing and deploying your application code. Analogy: this is like renting a fully furnished and equipped apartment. You move in and live your life. You don't worry about the plumbing, electricity, or maintaining the building itself. You just focus on what you do inside. Azure examples: Azure App Service, a service specifically designed for hosting web applications. You simply upload your code, e.g., a website, and Azure handles the servers, operating system, and patching. Azure SQL Database, a fully managed database service. You get a database to store your application's data, but you don't worry about the database server, operating system, or backups. Software as a Service, SaaS. What it is? SaaS delivers ready-to-use software applications over the internet, typically on a subscription basis. End users directly access and use the software without needing to install, manage, or troubleshoot anything. The cloud provider manages everything: the application, data, runtime, operating system, networking, and storage. Analogy: this is like taking a taxi. You just get in, tell the driver where to go, and enjoy the ride. You don't own the car, you don't maintain it, and you don't even manage the route, you just use the service. Azure examples: though often Microsoft products, they exemplify SaaS. Microsoft 365, e.g., Outlook, Word, Excel Online. You access your email, documents, and collaboration tools through a web browser or client application, and Microsoft handles all the underlying infrastructure and software updates. Dynamics 365, a suite of enterprise resource planning, ERP, and customer relationship management, CRM, applications provided as a service. It's important to understand the shared responsibility model here. With IaaS, you have maximum control, but also maximum responsibility. As you move towards PaaS and then SaaS, Microsoft takes on more of the responsibility for the underlying components, freeing you up to focus on your specific applications and data. However, even with SaaS, you, the user, are always responsible for your data, user access, and client-side security. 1.4 Cloud Deployment Models: public, private, and hybrid. Beyond the service models, clouds can also be deployed in different ways. Public cloud. This is what most people think of when they hear the cloud. Services are offered over the public internet by a third-party provider, like Microsoft Azure, and can be accessed by anyone who signs up. It's cost-effective due to shared infrastructure and offers immense scalability. Private cloud. This refers to cloud computing resources used exclusively by a single organization. It can be physically located on the company's own premises or hosted by a third-party service provider. A private cloud offers greater control and security, but lacks the agility and economic benefits of a public cloud. Hybrid cloud. This is a mix of public and private cloud environments. It uses technology that allows data and applications to be shared between them. For instance, a company might keep sensitive customer data in a private cloud environment while using the public cloud for web applications or less sensitive workloads. The key benefit is flexibility, leveraging existing infrastructure while taking advantage of the public cloud's scalability. 1.5 Why Microsoft Azure? Advantages and benefits. With several cloud providers in the market, why might an organization choose Microsoft Azure? Azure has rapidly grown to become one of the leading global cloud platforms, and for good reason: global reach and scale. Azure boasts a massive global network of data centers, more regions than any other cloud provider, ensuring low latency access for users worldwide and resilience against regional outages. Scalability and elasticity, on steroids. Azure truly shines here. Its architecture allows businesses to scale resources up or down almost instantly. This means you can handle massive traffic spikes without manual intervention and only pay for the extra capacity when you use it. Cost efficiency. With a pay-as-you-go model and various pricing options, like reserved instances for long-term commitments, Azure helps reduce capital expenditure and optimize operational costs. You avoid the expense of buying and maintaining your own hardware. Security and compliance. Microsoft has invested billions in cloud security. Azure offers built-in security controls, advanced threat detection, and adherence to hundreds of regulatory compliance standards, like HIPAA, GDPR, ISO 27001, helping organizations meet stringent industry requirements. Deep integration with Microsoft ecosystem. For businesses already using Microsoft technologies like Windows Server, SQL Server, Active Directory, or Microsoft 365, Azure offers seamless integration. This familiar landscape often makes the transition smoother and more efficient. Innovation and cutting-edge services. Azure is at the forefront of technological innovation, offering sophisticated services in artificial intelligence, AI, machine learning, Internet of Things, IoT, serverless computing, and blockchain. This means businesses have access to powerful tools to create intelligent, modern applications. Strong hybrid capabilities. Azure provides robust tools and services that allow seamless extension of on-premises data centers into the cloud, supporting complex hybrid environments. This is crucial for many enterprises that cannot move everything to the cloud overnight. Consider the story of a small graphic design studio. For years, they struggled with server upgrades every few years, costly software licenses, and limited storage for their ever-growing archive of high-resolution design files. When their old server finally sputtered, instead of buying a new one, they migrated their file storage to Azure Blob Storage and their project management software to an Azure-hosted database. The result? They cut their IT expenses by nearly 40%, never worried about running out of disk space again, and their designers could access files instantly, whether working from the studio or on location. Azure not only saved them money, but also enhanced their agility and peace of mind. 1.6 Common business use cases for Azure. Azure's versatility means it can be used for almost any computing need. Here are just a few common business applications. Website hosting. Running dynamic, scalable websites and web applications becomes much simpler and more reliable. Data backup and disaster recovery. Securely backing up critical data and entire applications to the cloud, ensuring business continuity even in the face of a disaster. Application development and testing. Providing scalable, on-demand environments for developers to build, test, and deploy new applications without delays. Digital transformation. Enabling businesses to modernize legacy applications and infrastructure, moving from outdated systems to agile cloud solutions. Data analytics and business intelligence. Collecting vast amounts of data, processing it, and deriving actionable insights to inform business decisions and predict future trends. Chapter 1 Summary. We've embarked on our Azure Odyssey by demystifying cloud computing. You now understand that the cloud isn't just a fluffy concept. It's a powerful model for delivering computing services on demand, freeing businesses from the burdens of owning and maintaining complex IT infrastructure. We've explored the core service models, IaaS, PaaS, and SaaS, each offering a different level of control and managed service. You also understand the versatility of public, private, and hybrid cloud deployments. Finally, we delved into the compelling reasons why so many organizations are choosing Microsoft Azure. From its global scale and cost efficiency to its built-in security and innovative services. This foundational understanding sets the stage for exploring the practical aspects of Azure in the chapters to come. Chapter 2, Your Azure Odyssey begins, setting up and navigating the portal. With a solid understanding of what cloud computing is and why Azure stands out, it's time to roll up our sleeves and get hands-on. This chapter will guide you through the exciting first steps: setting up your Azure account, understanding how resources are organized, and becoming familiar with the Azure portal, your central command center for all things Azure. Think of it as preparing your ship and getting your bearings before embarking on a grand voyage. 2.1 Getting started. Creating your Azure account. To begin your journey into Azure, you'll need an account. Microsoft makes it incredibly easy to get started, even offering a free account with significant benefits designed for exploration and learning. Prerequisites: you'll typically need two things to sign up. A Microsoft account. This is the same account you might use for Outlook.com, Xbox, or other Microsoft services. If you don't have one, you can create it during the sign-up process. A credit card. Even for the free account, a credit card is usually required for identity verification. Don't worry, you typically won't be charged unless you explicitly upgrade to a paid subscription or exceed the free service limits. This verification helps prevent abuse. The Azure free account, your learning sandbox. Microsoft generously offers an Azure free account, which is an excellent way to explore and experiment without immediate financial commitment. Here's what it typically includes: 12 months of free services, access to popular services like certain types of virtual machines, Azure SQL database, and Azure Blob Storage for a full year, up to specific usage limits. $200 credit for 30 days. A substantial monetary credit, the exact amount can vary by region, that you can use across virtually any Azure service within your first 30 days. This allows you to try more powerful or specialized services. Always free services. Certain services remain free indefinitely, even after your 12-month period and $200 credit expire, up to specific monthly limits, e.g., small amounts of storage, basic AI services. Walkthrough, simple steps to sign up. Visit the Azure website, open your web browser and navigate to azure.microsoft.com. Click Free Account or Start Free. Look for a prominent button to begin the sign-up process. Sign in Create Microsoft Account. You'll be prompted to sign in with an existing Microsoft account or create a new one. Enter personal information. Provide basic details like your country, name, and email. Identity verification. This is where you typically enter your phone number for a verification code and then your credit card details. Agree to terms, review and accept the subscription agreement. Welcome to Azure. Once complete, you'll be directed to the Azure portal, ready to explore. Keep a close eye on your usage within the free account period to avoid unexpected charges once the initial credit expires. Microsoft provides excellent tools within the portal to track this. 2.2 Understanding Azure subscriptions and resource groups. Now that you have an account, it's crucial to grasp how Azure organizes your resources. It uses a hierarchical structure designed for management, billing, and access control. Azure subscriptions, your billing container and boundary. Think of an Azure subscription like your utility bill account. It's a logical container that holds all your Azure resources and services, and it's the primary billing unit. Everything you deploy in Azure, virtual machines, storage accounts, databases, is associated with a subscription. Billing. Your monthly Azure bill is primarily generated at the subscription level. Limits. Subscriptions have service limits, such as the number of virtual CPUs you can deploy or the amount of storage you can provision. Access control. Access to resources within a subscription is managed at this level. Organizations often have multiple subscriptions for different departments, projects, or environments, e.g., one for development, one for production, to better manage costs and access. Resource groups, your project folders. Within a subscription, you organize your individual Azure resources into resource groups. A resource group is a logical container for related Azure resources. These resources could be a virtual machine, a storage account, a virtual network, and more basically, anything you might use for a specific project or application. Why use resource groups? Logical grouping. They help you organize your resources in a meaningful way. For example, all resources for your company's customer portal, application, web server, database, storage could go into one resource group called Customer Portal RG. Lifecycle management. When you delete a resource group, all resources within it are deleted. This makes it easy to clean up entire environments, e.g., for a temporary test project. Centralized management. You can apply management actions, such as security policies or access permissions, to an entire resource group, and those actions will apply to all resources within it. Cost management, indirectly. While billing is at the subscription level, resource groups help track costs by project or application, providing granular insights. Analogy. If your Azure subscription is your wallet, then resource groups are like separate project folders within that wallet. Each folder contains all the receipts, resources, for a specific project, making it easy to see where your money went for that particular effort and to clean it up when the project is done. 2.3. Navigating the Azure portal. Your command center. The Azure portal, portal.azure.com, is a web-based, unified console that provides an alternative to command line tools. It's your primary interface for managing and monitoring your Azure resources. Let's explore its main components. Dashboard. This is the personalized landing page when you log in. You can customize it by adding tiles that display key metrics, resource statuses, or quick links to frequently used services. It's like your personal control panel, showing you the most important information at a glance. Global Search Bar, a powerful tool located at the top of the portal. Use it to quickly find specific resources, services, documentation, or even marketplace offerings. Start typing, and it intelligently suggests results. This is often the fastest way to get to what you're looking for. Left navigation pane. On the left side, you'll find a collapsible menu. This provides access to Home, takes you back to your dashboard. All services, a comprehensive list of every service Azure offers, categorized for easy browsing. Resource groups, a direct link to view and manage all your resource groups. Favorites, you can pin frequently used services, like virtual machines, storage accounts, or resource groups, to this section for quick access. Resource panes. When you click on a service or resource, a new pane typically opens, displaying details, configurations, and monitoring data specific to that resource. Most resource panes will have an overview section and detailed sections for configuration, monitoring, and settings. Cloud Shell, more advanced. While not for daily basic navigation, you might notice a small icon, often, at the top of the portal. This launches Azure Cloud Shell, a browser-based command line interface that includes PowerShell and Bash. It's a powerful tool for more advanced users who prefer scripting or command line interaction and don't want to install tools locally. Notifications and activity log. Notifications bell, top right corner, provides real-time updates on deployments, operations, and alerts. If a resource is successfully created or an operation fails, you'll see a notification here. Activity log shows a history of all operations performed on your Azure resources, who performed them, and when. This is invaluable for troubleshooting and auditing. Don't be overwhelmed by the sheer number of options. Start simple, focus on the services you're learning about, and use the search bar often. The portal is designed to be intuitive, and you'll become more comfortable with it over time. 2.4. Managing your Azure resources. Create, monitor, delete. Once you're familiar with navigating the portal, the next step is performing basic operations. Creating, monitoring, and cleaning up resources. Creating a resource. The process to create almost any resource in Azure generally follows these steps. Search for the service. Use the global search bar, e.g., type virtual machine or storage account. Select the service. Click on the relevant service from the search results. Click Create. On the Services Overview page, you'll typically see a Create button. Fill out configuration forms. Azure will guide you through a series of tabs or sections, asking for details required to configure the resource. This includes subscription. Select which subscription this resource belongs to. Resource group. Create a new one or select an existing one. Region. Choose the Azure Data Center location, e.g., East US, West Europe. This is important for performance and data residency. Naming. Give your resource a unique, descriptive name. Specific settings. Settings unique to the resource, e.g., VM size, storage redundancy. Review plus Create. Azure will validate your configuration. You can then review a summary and click Create. Deployment. Azure will deploy the resource, which can take a few seconds to several minutes depending on the complexity. You'll see progress in your notifications. Example. Creating a storage account. A simple example. To create an Azure storage account, a versatile service for storing various types of data. Search for storage accounts in the top search bar. Click Storage Accounts under Services. Click the plus Create button. Fill in the basics. Subscription, new or existing resource group, a unique storage account name, and a region. Choose Performance, Standard, Premium, and Redundancy. See Chapter 4 for details, but LRS is cheapest for learning. Click Review plus Create, and then Create. Monitoring Basics. Azure provides basic monitoring for virtually all resources. Once a resource is deployed, navigate to its specific resource pane. You'll often find Overview. Key metrics like CPU usage, network activity, or storage capacity. Monitoring section. Dedicated sections for metrics, activity log, and diagnostic settings to get deeper insights. This is where you can see how your resources are performing. Resource tags. Organization is key. As you deploy more resources, organization becomes critical. Tags are arbitrary key-value pairs, name. Value that you can apply to your Azure resources, resource groups, and even subscriptions. Usage. You might tag resources with environment, production, project, website redesign, owner, Jane Doe or cost center, marketing. Benefits. Tags are invaluable for organization, easily categorize and find resources. Cost management. Filter billing data by tag to see costs for specific teams or projects. Automation. Use tags in scripts or Azure policies to automate management tasks. Deleting resources. Clean up to save costs. A fundamental principle in cloud computing is pay as you go. If you leave resources running that you no longer need, you will continue to be charged for them. Therefore, knowing how to delete resources is as important as creating them. The simplest way to delete a set of related resources is to delete their surrounding resource group. Navigate to Resource Groups in the left navigation pane. Select the resource group you wish to delete. Click the Delete Resource Group button at the top. You'll be asked to type the resource group name to confirm a safety measure. Click Delete. Always exercise caution when deleting resources or resource groups, especially in environments other than your learning sandbox. Deleting a resource group irrevocably removes everything within it. 2.5 Azure Mobile App, managing on the go. For those times when you're away from your computer but need to check on your Azure resources, Microsoft offers the Azure Mobile App, available for iOS and Android. While not for complex configuration, it allows you to monitor the status of your resources, view your dashboards, check alerts, execute basic commands via Cloud Shell. It's a convenient tool for staying connected to your cloud environment. Chapter 2 Summary. Congratulations! You've taken your first practical steps into the Azure cloud. You've learned how to set up your free account, navigate the powerful Azure portal, and understand the core organizational concepts of subscriptions and resource groups. You also have a basic grasp of creating, monitoring, and correctly deleting resources. This hands-on foundation is crucial as we delve deeper into specific Azure services in the chapters to come. Remember, practice makes perfect, so don't hesitate to experiment within your free account environment. Chapter 3, The Workhorses of the Cloud, Understanding Azure Compute Services. In the physical world, compute refers to the processing power of a computer, its ability to run programs, perform calculations, and execute instructions. In the cloud, compute services are precisely where your applications, processes, and workloads actually run. If you think of your data as the fuel for your business and networking as the roads connecting everything, then compute services are the engines and vehicles that make everything move. Azure offers a diverse range of compute options, each designed for different needs and offering varying levels of control versus management. This chapter will introduce you to these workhorses, helping you understand which engine is best suited for your particular cargo. 3.1 Introduction to Compute in Azure, where workloads run. Imagine you have a new software application you want to make available to your customers. Where does it live? How does it run? In the traditional on-premises world, you'd buy a physical server, install an operating system, and deploy your application. In Azure, you don't buy physical servers, but you still need a place for your application to execute. That's where Azure's compute services come in. The variety of options in Azure is a key strength. You can choose to have almost complete control over your virtual servers, like having your own garage and parts to build a custom car, or opt for highly managed services where Microsoft handles nearly all the underlying infrastructure, letting you focus purely on your application code, like simply hailing a self-driving taxi. 3.2 Azure Virtual Machines, VMS, your own servers in the cloud. Concept: Azure Virtual Machines, VMS, are the cloud equivalent of a physical computer. They are virtualized servers that provide infrastructure as a service, IaaS. When you provision an Azure VM, you're essentially getting a virtualized operating system, Windows or Linux, running on Microsoft's global infrastructure. You have full control over the operating system, its configuration, and the applications you install on it. Use cases: lift-and-shift migrations. If you have existing applications running on physical servers or VMS in your data center, you can often lift them as is and shift them to Azure VMS without significant code changes. This is a common first step for many cloud migrations. Running specialized software. When your application requires a very specific operating system configuration or uses software that isn't compatible with more managed services. Development and test environments. Quickly spin up and tear down development or testing servers as needed. Consistent environments. Ensure all your development, test, and production environments are identical, reducing "it worked on my machine" issues. Benefits: flexibility and control. You have root administrator access to the operating system, allowing you to install almost any software and configure it precisely to your needs. Familiar environment. For IT professionals used to managing physical servers, managing Azure VMS feels very similar. Considerations: management overhead. While Microsoft manages the underlying hardware, you're still responsible for managing the operating system, patching, security updates, installing software, and ensuring applications run correctly. This means a higher level of operational burden compared to more managed services. Scaling can be manual. While you can easily resize VMS or create more instances, setting up automatic scaling for VMS requires more configuration than with services like Azure App Service. Many companies begin their cloud journey with VMs. For example, a mid-sized manufacturing company had an aging server running their critical inventory management system. Instead of investing in a new physical server and dealing with setup and maintenance, they lifted and shifted their existing application to an Azure VM. This saved them significant upfront capital, reduced their IT team's physical maintenance burden, and provided them with a more reliable, scalable infrastructure without having to rewrite their core application. 3.3 Azure App Service, powering web apps and APIs. Concept: Azure App Service is a platform as a service PaaS, offering specifically designed for hosting web applications, REST-TFL APIs, and mobile backends. With App Service, you simply deploy your code, and Azure handles all the underlying infrastructure: the operating system, web server, like IIS or Apache, framework runtimes, and automatic scaling. Supported languages. App Service supports a wide range of popular programming languages and frameworks, including Net, Java, Node.js, Python, PHP, and Ruby. Benefits: automatic scaling. App Service can automatically scale your application up more powerful server or out more server instances, to handle fluctuating traffic loads, ensuring your website stays responsive. Built-in security. Azure handles network security, patching, and many other security considerations for the platform. Simplified deployment. Integrates well with popular development tools and provides features for continuous deployment from source code repositories like GitHub. No server management. You never have to log into a server to install updates or configure a web server. Azure takes care of it all. Use cases, websites and web applications. Ideal for public-facing websites, e-commerce platforms, and internal business applications. RESTful APIs, building backend services for mobile apps or other applications. Single-page applications, hosting client-side frameworks with a backend API. Analogy, imagine you're a baker. With Azure VMS, you're buying a plot of land, building your bakery, installing ovens, and managing everything. With Azure App Service, it's like you're leasing a fully equipped, modern kitchen. You just bring your ingredients, your application code, bake your cakes, and Azure handles the oven maintenance, electricity, and even helps sell them. You focus purely on the baking. 3.4 Azure Container Instances, ACI, and Azure Kubernetes Service, AKS, the container revolution. In recent years, containers have revolutionized how applications are packaged and deployed. Containers briefly. Think of a container as a lightweight, standalone, executable package of software that includes everything needed to run it. Code, runtime, system tools, system libraries, and settings. They ensure that an application runs consistently across different environments because everything it needs is bundled together. Benefits of containers, consistency. It works on my machine becomes it works in this container, which means it works everywhere. Portability. Containers can be deployed almost anywhere, developer's laptop, on-prem server, any cloud. Efficiency. Containers are much lighter than traditional virtual machines, allowing more applications to run on the same infrastructure. Faster deployment. Containers start up much faster. Azure Container Instances, ACI, for simple container deployments. Concept. ACI allows you to run individual Docker containers directly in Azure without having to provision or manage any virtual machines or orchestration tools. It's the quickest way to run a container in the cloud. Use cases, simple batch jobs, running short-lived tasks, e.g. data processing scripts. Development testing, quickly test a containerized application. Burst workloads, providing temporary compute for unexpected spikes in demand. Azure Kubernetes Service, AKS, for orchestrating complex containerized applications. Concept. Kubernetes is an open-source system for automating deployment, scaling, and management of containerized applications. AKS is Azure's fully managed Kubernetes service. It takes away the operational complexity of running a Kubernetes cluster, allowing you to focus on your applications. Use cases, microservices architectures, breaking down large applications into smaller, independent services running in containers. Large-scale, distributed applications, applications that require high availability, complex scaling, and self-healing capabilities. Continuous integration, continuous deployment, CI/CD, streamlining the process of delivering software updates. Containers, especially with AKS, represent a cutting-edge way to deploy and manage modern applications. For example, a rapidly growing online gaming company used to struggle with deploying updates to their game servers. By moving to a microservices architecture on AKS, they could deploy updates to individual game components independently, with zero downtime, and automatically scale their server fleet to match player demand, ensuring a smooth experience for millions of users worldwide. 3.5 Azure Functions, the magic of serverless compute. Concept. Azure Functions is Microsoft's serverless compute service and a powerful platform as a service PaaS offering. With functions, you write small, event-driven pieces of code, called functions, that run in response to specific triggers, such as an HTTP request, a message arriving in a queue, or a new file being uploaded to storage. The magic, you don't provision or manage any servers. Azure automatically allocates compute resources to run your code when an event occurs, and you only pay for the actual time your code is running. Benefits. true paper execution. If your function isn't running, you're not paying. This can be incredibly cost-effective for intermittent workloads. Automatic scaling. Azure automatically scales your functions to handle any load, from a single request to millions, without you needing to configure anything. Focus on code. Your sole responsibility is to write the logic of your function. Azure handles all the server management, patching, and infrastructure. Use cases, processing data, resizing images after they're uploaded, validating data, performing background calculations. Real-time stream processing, reacting to events from IoT devices or data streams. Chatbot backends/API endpoints. Simple, lightweight APIs that respond to requests. Scheduled tasks, running code on a timer, e.g., daily reports, database cleanups. Analogy, imagine a vending machine. You put in a request like selecting a snack, and the machine performs an action, dispenses the snack. You don't see or manage the internal mechanics, the power supply for the machine, or its physical location. You just get the result, and you only pay when you use it. Azure functions are like that. An event happens, your code runs, a result is produced, and you're billed for that exact execution. A startup building a document processing service leveraged Azure functions. When a user uploads a PDF, an Azure function automatically triggers, extracts text, and stores it in a database. This allowed them to build a highly scalable, cost-efficient, and responsive system without having to worry about managing servers for their fluctuating processing needs. 3.6. Choosing the right compute service. With so many powerful options, how do you decide? Here's a simple decision-making framework. Azure Virtual Machines, IaaS. Choose when you need maximum control over the operating system and software stack. Ideal for lift-and-shift, migrations of existing applications, specialized software, or when you need a familiar server management experience. Azure App Service, PaaS. Choose for hosting web applications, APIs, or mobile backends where you want to abstract away server management and benefit from built-in scaling and deployment features. Focus on your code, not infrastructure. Azure Container Instances, ACI. Choose for simple, single-container workloads where you need to run a container without configuring a full orchestration system like Kubernetes. Great for quick tasks or dev/test. Azure Kubernetes Service, AKS. Choose for complex, distributed applications built using microservices, where you need robust container orchestration, advanced scaling, and a highly available environment. Azure Functions, Serverless PaaS. Choose for event-driven, short-lived code executions where you want absolute minimal server management and a cost model based purely on execution time. Ideal for processing, reacting to events, or scheduled tasks. Often, a single application might even combine several of these. For instance, a complex application might use App Service for its web front end, AKS for its backend microservices, and Azure Functions for intermittent data processing tasks triggered by events. Chapter 3 Summary. Azure's compute services provide the horsepower for every type of workload imaginable. From the granular control of virtual machines to the effortless scalability of App Service, the portable power of containers, ACI and AKS, and the ultimate paper execution model of serverless functions, there's an engine for every task. Understanding these options empowers you to select the most efficient, scalable, and cost-effective solution for your applications, allowing you to build and run diverse workloads in the cloud with confidence. Next, we'll explore where all your application's valuable data will reside. Chapter 4. Data Storage in the Cloud, Azure's Versatile Storage Options. If compute services are the engines that run your applications, then data storage services are the fuel tanks and warehouses that hold all the vital information your applications need and produce. From customer photos and product catalogs to financial records and sensor data, every application relies heavily on efficient, secure, and scalable storage. In the world of traditional IT, choosing storage involves purchasing physical hard drives, network-attached storage, NAS, or storage area networks, SANs, then managing their capacity, performance, and backups. In Azure, this complexity vanishes. You simply provision the type of storage you need, and Azure handles the underlying hardware, redundancy, and scaling. This chapter will guide you through Azure's extensive storage options, highlighting their unique characteristics and best use cases. You'll discover that Azure offers a specialized solution for almost every data requirement. 4.1 Introduction to Azure Storage, a place for all your data. Azure Storage is a highly available, massively scalable, durable, and secure cloud storage solution. Its primary goals are durability and high availability. Ensure your data is safe and accessible, even in the event of hardware failures or natural disasters, by replicating it across multiple physical locations. Scalability. Instantly grow or shrink your storage capacity to meet your application's demands, from gigabytes to petabytes, without any manual intervention. Security. Provide robust encryption for data both at rest and in transit, along with fine-grained access controls. Cost efficiency. Offer various options and tiers, allowing you to pay only for the storage you consume and optimize costs based on access patterns. The reason for so many different storage options in Azure is simple. Different types of data have different needs. A video file has very different requirements than an active database record or a log file. Azure provides specialized services to meet these diverse demands. 4.2 Azure Blob Storage, storing unstructured data at scale. Concept: Azure Blob Storage is Microsoft's object storage solution for the cloud. It's designed to store massive amounts of unstructured data. Unstructured means data that doesn't fit neatly into a traditional row and column database, such as text and binary data. Photos, videos, audio files, documents, backups, log files, large datasets for analytics. Types of blobs: block blobs, ideal for storing digital media, images, videos, documents, backup files, and other discrete objects up to many terabytes in size. Most common type: append blobs, optimized for append operations, like logging data from applications or IoT devices. You can only add new blocks to the end of an append blob. Page blobs, optimized for random read-write operations and are primarily used to store virtual hard drive (VHD) files for Azure virtual machines. Access tiers. A crucial feature of blob storage is its access tiers, which allow you to optimize costs based on how frequently you expect to access your data. Hot tier, for data that is accessed frequently. This tier has higher storage costs but lower access costs. Cool tier, for data that is infrequently accessed, stored for at least 30 days. This tier has lower storage costs than hot but higher access costs. Think of it for short-term backups or older logs. Archive tier, for rarely accessed data, stored for at least 180 days with flexible latency requirements, hours to retrieve. This tier has the lowest storage costs but the highest access costs and slowest retrieval times, ideal for long-term archives or compliance data. Use cases: media streaming, storing and streaming video and audio files directly to users. Unstructured data for analytics, creating data lakes to feed big data analytics workflows. Backup and disaster recovery, storing backups of databases, virtual machines, and on-premises data. Content storage, hosting files for websites and web applications, images, CSS, JavaScript. Consider a global media company with an enormous library of video footage, photos, and audio recordings. They use Azure Blob Storage to house all this content. Recent, frequently accessed footage for current projects lives in the hot tier for quick retrieval. Older, less frequently accessed but still relevant archives are moved to the cool tier, significantly reducing their monthly storage bill. Historical footage, rarely needed but required for long-term preservation, is pushed to the extremely cost-effective archive tier. This strategic use of access tiers allows them to manage petabytes of data efficiently and affordably. 4.3 Azure Files, cloud file shares with familiarity. Concept: Azure Files offers fully managed file shares in the cloud that are accessible via the industry-standard Server Message Block (SMB) protocol. This means you can mount an Azure file share like a traditional network drive on Windows, Linux, or macOS machines, either in your Azure VMS or even from your on-premises network. Use cases: lift-and-shift applications, ideal for traditional applications that rely on a network file share for data storage, e.g., shared configuration files, user profiles, content management systems. Shared application settings. Centralizing configuration files for applications running on multiple VMs. Developer tooling, providing a consistent file share for development environments. Home directories, storing user data for virtual desktop environments. Azure Files bridges the gap between traditional file servers and cloud storage, allowing existing applications to leverage the cloud without requiring extensive re-architecting. 4.4 Azure Disk Storage, the drives for your virtual machines. Concept: Azure Disk Storage provides block-level storage volumes for Azure virtual machines. When you create a VM, you attach a virtual hard disk, VHD, to it, which is effectively an Azure disk. These disks are persistent, meaning the data on them remains even if the VM is shut down or moved. Types of disks: performance tiers. Standard HDD hard disk drives. Cost-effective magnetic drives, suitable for development and test workloads or infrequently accessed data where performance isn't critical. Standard SSD solid-state drives, more performant than HDDs, suitable for web servers, lightly used production applications, and development test. Premium SSD, high-performance solid-state drives, designed for I/O-intensive workloads like production databases, enterprise applications, and high-performance computing. Ultra Disk, the highest performance tier, delivering consistently low latency and high IOPS input-output operations per second for the most demanding workloads, e.g., top-tier databases, mission-critical applications. Use cases: operating system disks, where the VMS operating system is installed. Data disks, for storing application data, databases, and other files that require high performance and persistence. Think of Azure disks as the virtual versions of the SSDs or HDDs you'd find inside a physical server, optimized for performance and availability in the cloud. 4.5 Other niche storage options, briefly mentioned. While blob, files, and disk storage cover most common needs, Azure offers specialized storage services for particular use cases. Azure Table Storage, a NoSQL key-value store for storing large amounts of structured, non-relational data cheaply. Ideal for simple, flat structures like lookup tables or sensor data that doesn't need complex queries. Azure Queue Storage, a service for storing large numbers of messages. It's used for asynchronous communication between application components, decoupling them to ensure scalability and reliability. 4.6 Storage Accounts, the container for your storage services. Most of the services discussed above, blob storage, file shares, queues, and tables, are created within a parent resource called an Azure Storage Account. A storage account provides a unique namespace for your data, making it accessible from anywhere in the world over HTTP or HTTPS. When you create a storage account, you also specify its redundancy options. These determine how your data is replicated to ensure durability and high availability. Locally redundant storage, LRS. Data is replicated 3 times within a single data center in the chosen region. This offers excellent durability, but doesn't protect against a data center-wide outage. Zone redundant storage, ZRS. Data is replicated 3 times across 3 different availability zones, physically separate locations within a region with independent power, cooling, and networking. Protects against a data center-level outage. Georedundant storage, GRS. Data is replicated to a secondary paired region, hundreds of miles away, in addition to LRS in the primary region. This offers the highest level of durability, protecting against regional disasters. Read access georedundant storage, RAW-GRS. Similar to GRS, but allows read access to the data in the secondary region. Choosing the right redundancy option is a balance between durability needs and cost, with higher redundancy options typically costing more. 4.7 Security and management of Azure storage. Azure storage accounts include robust security features. Access keys. Primary and secondary keys provide full administrative access to the storage account. Shared access signatures, SAS. Granular, time-limited, and permission-specific access to resources in your storage account. Ideal for providing temporary access to files without exposing primary keys. Azure AD integration. For more comprehensive access control, you can integrate with Azure Active Directory, covered in Chapter 9, and use role-based access control, RBAC. Encryption: data is encrypted at rest, automatically by default, and in transit via HTTPS. For example, a drone delivery company uses Azure Blob Storage to store all their flight logs and camera footage. To ensure security, they use shared access signatures to provide limited-time, read-only links for specific log files to their maintenance crew, preventing unauthorized access to the entire storage account. Chapter 4 Summary: Azure's storage services offer a powerful and versatile suite of options for managing every type of data your applications need. From unstructured object storage in blob storage, familiar file shares via Azure Files, and high-performance disks for your virtual machines, Azure ensures your data is secure, highly available, and scalable. Understanding these options allows you to choose the most appropriate and cost-effective storage solution for your specific data needs, providing a robust foundation for your cloud applications. Next, we'll explore how to connect all these pieces together safely and efficiently using Azure's networking capabilities. Chapter 5: Connecting the Dots. Azure Networking Essentials. Imagine building a magnificent city. Buildings, houses, parks, and factories spring up everywhere, but none of it truly functions until you lay down the roads, bridges, and utilities. In the world of cloud computing, networking is that critical infrastructure. It's what allows your virtual machines to talk to your databases, your web applications to serve content to users, and your on-premises systems to securely connect to your cloud resources. Azure Networking provides a vast array of services that allow you to build, manage, and secure your own private networks in the cloud, connect them to the internet, or even extend your existing corporate network into Azure. While the topic can seem daunting at first glance, this chapter will simplify the core concepts, helping you understand how your Azure resources communicate effectively and securely. 5.1 The Foundation. Azure Virtual Networks, VNets. Concept: an Azure Virtual Network, VNet, is the fundamental building block for your private network in Azure. Think of it as your own isolated, private, and customizable network segment in the cloud, where your Azure resources communicate securely with each other, the internet, and your on-premises networks. When you create a VNet, you define your own private IP address ranges, e.g., 10.0.0.0/16, just as you would in a traditional data center. No other organization can access or use your VNet unless you explicitly grant them permission. Key features: custom IP address space. You define the private IP address range for your VNet. DNS configuration. You can use Azure's default DNS or configure your own custom DNS servers. Security. Built-in security features and integration with other Azure security services ensure your VNet is protected. Use cases. Isolating environments. Create separate VNets for development, testing, and production environments to prevent cross-contamination. Hosting multi-tier applications. Place web servers in one VNet segment, application servers in another, and databases in a third, controlling the flow of traffic between them. Hybrid connectivity. Extend your on-premises network securely into Azure, making your cloud resources feel like they are part of your local network, covered below. 5.2 Subnets. Organizing your network within a VNet. Within a VNet, you can define one or more subnets. A subnet, short for subnetwork, is a logical division of your VNet's IP address space. Purpose: better organization. Subnets help you organize and segment your network resources. For example, you might place all your web servers in a web tier subnet, application servers in an app tier subnet, and databases in a data tier subnet. Enhanced security. Subnets are crucial for applying network security rules. You can apply different security policies to each subnet, controlling what traffic can flow into and out of them. This segmentation is incredibly important for maintaining a secure and manageable cloud environment. 5.3 Network Security Groups, NSGS, your cloud firewalls. Concept: network security groups, NSGS, are fundamental to securing your Azure virtual networks. Think of an NSG as a set of firewall rules that allow or deny incoming, inbound, and outbound network traffic to or from Azure resources. You can associate an NSG to either a subnet or an individual network interface, NIC, of a virtual machine. How they work: each NSG contains a list of security rules. Each rule specifies priority, a number indicating the order in which rules are processed. Lower numbers are processed first. Source destination: specific IP addresses, IP ranges, or service tags, predefined groups of IP addresses for Azure services. Port: the communication port, e.g., port 80 for HTTP, port 443 for HTTPS, port 22 for SSH. Protocol: TCP, UDP, or any. Action: allow or deny. Analogy: imagine your VNet as a building with different rooms, subnets, and doors, VMS. NSGs are like security guards stationed at the entrances and exits of these rooms or at each individual door. They check special passes, the rules, for anyone trying to enter or leave, only allowing traffic that meets their criteria. For example, you might have an NSG rule that only allows web traffic, port 8443, from the internet to your web server subnet, but denies direct access from the internet to your database subnet. Properly configured NSGs are your first line of defense in protecting your applications and data in Azure. 5.4 Connecting to your Azure network, on-premises and public internet. Once your VNet is set up, you'll need ways to connect it to the outside world and often to your existing corporate network. Public IP addresses. For some Azure resources, like certain VMS or load balancers, to be directly accessible from the internet, they need to be assigned a public IP address. These are global, unique IP addresses used for external communication. Azure provides options for both static, fixed, and dynamic changing public IPs. VPN gateway. Secure connection over the public internet. An Azure VPN gateway allows you to create secure connections between your Azure VNets and your on-premises networks over the public internet. It works like this. Site-to-site VPN connects your entire on-premises network, e.g., your office LAN, to an Azure VNet. It's like extending your on-premises network virtually into Azure. Point-to-site VPN allows individual client computers, e.g., a remote employee's laptop, to connect securely to an Azure VNet. VPN gateways are relatively inexpensive and simple to set up, making them a popular choice for hybrid connectivity. ExpressRoute, private, dedicated high-bandwidth connectivity. Azure ExpressRoute provides a private, dedicated, high-bandwidth connection between your on-premises network and Azure data centers. Unlike VPN gateways, ExpressRoute connections do not go over the public internet, offering higher security, reliability, and consistent performance with lower latency. Use cases for ExpressRoute: large-scale data migrations, moving massive amounts of data to Azure. Mission-critical applications, applications requiring guaranteed performance and uptime. Hybrid applications, where parts of an application run on-premises and parts in Azure, requiring seamless, high-speed integration. Think of VPN gateway as taking a secured, encrypted tunnel on a public road, while ExpressRoute is like building your own private, dedicated highway straight to the Azure data center. 5.5 Load balancers and application gateways. Distributing traffic. When you have multiple instances of an application, e.g., several web servers handling your website, you need a way to efficiently distribute incoming network traffic across them. This is where load balancing comes in. Azure Load Balancer. This is a high-performance, low-latency layer for TCP/UDP load balancer. It distributes network traffic to virtual machines or instances within the same Azure VNet or to external internet-facing services. It ensures high availability by routing traffic away from unhealthy instances. Azure Application Gateway. This is a more advanced Layer 7 HTTP/HTTPS load balancer. It's designed specifically for web applications. Besides distributing traffic, it can perform more intelligent routing based on URL paths, host headers, and can include a web application firewall, WAF, to protect your web applications from common web vulnerabilities, like SQL injection or cross-site scripting attacks. Analogy: A regular Azure load balancer is like a traffic cop at a busy intersection, directing cars, network packets, evenly to different lanes, servers. An Azure Application Gateway is like a more sophisticated dispatcher for a fine dining restaurant. It doesn't just direct diners, but can also inspect their reservations, URL paths, check them against a blacklist, WAF, and ensuring they go to the right part of the restaurant. 5.6 Azure DNS. Managing your domain names. Concept. Azure DNS is a hosting service for DNS, domain name system, domains. DNS translates human-readable domain names, like www.example.com, into machine-readable IP addresses, like 20.10.10.5. Azure DNS provides a highly available and performing way to manage your domain name records using Microsoft's global infrastructure. Benefits: high availability, built to be resilient and globally distributed. Integration: seamlessly integrates with your other Azure resources. If your website is hosted in Azure, you'll likely configure your domain name using Azure DNS to point to your Azure App Service, Load Balancer, or other appropriate service. 5.7 Network Monitoring Basics. While a deep dive into monitoring comes later, Chapter 10, it's important to know that Azure provides robust tools to monitor your network health and performance. Azure Monitor, which we'll discuss more fully, can collect metrics for your VNets, NSGS, and other networking components, allowing you to visualize traffic flows, identify bottlenecks, and troubleshoot issues. You can gain insights into who is accessing your resources, from where, and how much data is being transferred. Chapter 5 Summary. Networking is the unsung hero of cloud computing, quietly enabling all your applications and services to communicate effectively and securely. We've explored the foundational concepts like Azure Virtual Networks, VNets, and subnets, which provide isolated network environments. You've learned how network security groups, NSGS, act as your cloud firewalls, controlling traffic flow. We also covered various options for connecting your Azure network to the public internet and your on-premises data centers, from secure VPNs to high-speed ExpressRoute. Finally, you saw how load balancers and DNS ensure your applications are always available and accessible. With these essential networking building blocks, you can construct a resilient and secure cloud infrastructure for your applications. Next, we'll dive into the nuances of storing and managing information, specifically within Azure's diverse database services. Chapter 6. Databases Demystified. Storing and managing your information in Azure. In the world of applications, data is king. Whether it's customer profiles, product inventories, sensor readings, or financial transactions, virtually every application relies on databases to store, organize, and retrieve information. Imagine trying to run an online store without a system to track orders or a social media platform without a way to save user posts. It's impossible. Traditionally, managing databases has been a significant burden for IT departments. It involves licensing expensive software, provisioning powerful servers, tirelessly patching operating systems and database engines, performing backups, and ensuring high availability and disaster recovery. All of this requires highly specialized and often scarce expertise. Azure, once again, offers a liberating solution with its managed database services. Microsoft takes on the operational complexities of running the database infrastructure, allowing you to focus on developing your applications and extracting value from your data. This chapter will demystify Azure's primary database offerings, guiding you through the choices available for both structured and unstructured data. 6.1 Introduction to Azure Database Services. The heart of your applications. Azure's database portfolio is vast and caters to almost any data need. The primary benefit of using a managed database service in Azure is that you delegate the mundane, repetitive, and often complex tasks of database administration to Microsoft. This includes provisioning, quickly spinning up new database instances, patching and updates. Azure automatically keeps the database software up to date. Backups. Automated, geo-redundant backups ensure your data is safe. High availability. Built-in mechanisms to ensure your database remains accessible even if a server fails. Scaling. Easily scale performance and storage capacity up or down as your needs change. This shift allows development teams to accelerate their new projects and IT operations to free up valuable time from maintenance to focus on more strategic initiatives. 6.2 Relational databases. The SQL family in Azure. Concept: relational databases are the most traditional and widely used type of database. They store data in structured tables with rows and columns, much like a spreadsheet. Key characteristics include structured query language, SQL, used to manage and query the data. Relationships. Data across different tables is linked by common fields, e.g., a customer table linked to an orders table. ACID properties. Ensure data integrity by guaranteeing atomicity, consistency, isolation, and durability for transactions. Azure SQL Database, your managed Microsoft SQL Server. Concept: Azure SQL Database is a fully managed, intelligent, relational database service built on the latest stable version of the Microsoft SQL Server database engine. It is a platform as a service (PaaS) offering, meaning Microsoft manages the underlying infrastructure, operating system, and SQL Server software. Benefits: high availability and disaster recovery, built-in auto failover, backups, and geo-replication. Intelligent performance, adaptive query processing, automatic tuning, and threat detection. Scalability, easily scale compute and storage resources independently, on the fly. Security, encryption at rest and in transit, network security features, and integration with Azure Active Directory. Use cases: online transaction processing, OLTP, applications. High-volume transaction systems like e-commerce, banking, and point-of-sale. Traditional business applications, CRM, ERP systems, and other line-of-business applications. Web and mobile applications. Backend databases for new applications requiring structured data. For example, a regional bank utilized Azure SQL Database for its core online banking application. The ability of Azure to automatically handle backups, apply security patches, and ensure high availability meant their team could focus on developing new customer-facing features. Confident that their sensitive financial data was both secure and constantly available. Azure Database for MySQL, PostgreSQL, and MariaDB. Open source power. Concept: Azure also offers fully managed services for popular open-source relational database engines. MySQL, PostgreSQL, and MariaDB. Like Azure SQL Database, these are PaaS offerings, abstracting away the infrastructure management. Why open source? Cost-efficient. Often come with more flexible licensing models. Community support. Benefit from large, vibrant developer communities. Flexibility. Broad support for various programming languages and frameworks. Use cases: web applications. Popular choices for web backends using LAMP, Linux, Apache, MySQL, PHP, Python, Perl, or similar stacks. New development projects. Ideal for startups or projects seeking to leverage open-source ecosystems. Geospatial and analytical workloads. PostgreSQL, in particular, is well regarded for its advanced features, including strong support for geospatial data, PostGIS. Analogy for relational databases. Think of a meticulously organized central library. Each book data record has a specific shelf table, a unique call number, primary key, authors' attributes, and categories. The librarian Azure ensures all books are cataloged correctly, placed in the right spots, always available, and manages new editions efficiently. Anyone wanting a book must go through the librarian to ensure the system remains orderly. 6.3 NoSQL databases. Flexibility with Azure Cosmos DB. Concept: NoSQL. Not only SQL databases are a diverse group of database technologies designed to handle large volumes of unstructured, semi-structured, and rapidly changing data that doesn't fit well into the rigid row and column structure of relational databases. They prioritize flexibility, horizontal scalability, and high performance over strict consistency models. Azure Cosmos DB, the planet-scale database. Concept: Azure Cosmos DB is Microsoft's globally distributed, multi-model NoSQL database service. It means you can store various types of data, documents, key value pairs, graphs, column family within the same service, and have it automatically replicated and available across multiple Azure regions worldwide. Key benefits: global distribution. Data can be transparently replicated across any number of Azure regions with a single click, bringing data closer to users for ultra-low latency access. Multi-API support. Cosmos DB supports multiple popular NoSQL APIs, including SQL Core API for document data (JSON), MongoDB API for MongoDB applications, Cassandra API for Apache Cassandra applications, Gremlin API for graph databases, Table API for Azure Table Storage applications. This allows developers to leverage their existing NoSQL skills and tools. Guaranteed low latency. Offers financially backed service-level agreements, SLAs for latency, throughput, availability, and consistency. Automatic scaling. Cosmos DB can automatically and instantly scale throughput and storage. Use cases: IoT, Internet of Things, ingesting and processing massive streams of sensor data. Gaming, storing player data, game states, and leaderboards for globally distributed games with high concurrency. Mobile applications, providing a responsive, globally accessible backend for mobile apps. Real-time analytics, applications requiring immediate insights from rapidly changing data. E-commerce, product catalogs, user preferences, shopping carts. A major global gaming company uses Azure Cosmos DB as the backend for their popular online multiplayer game. By distributing player data across multiple Azure regions using Cosmos DB, they ensure that a player in Japan experiences the same lightning-fast data access as a player in New York, leading to a consistently smooth and engaging gaming experience, regardless of where they are in the world. Analogy for NoSQL databases. Imagine a bustling art studio. Instead of strict library rules, artists' applications can jot down notes, data in sketchbooks, on canvases, or even stick them on a whiteboard. There's no fixed structure for these notes. The Studio Manager, Azure Cosmos DB, effortlessly collects all these pieces, ensures they're instantly available to anyone who needs them, and can even make copies to other studios around the world, all while adapting to new ways of storing information. 6.4 Databases for analytics. Azure Synapse Analytics and Azure Databricks, brief mention. For very large-scale data warehousing and big data analytics, where you're processing petabytes of historical data for business intelligence rather than live transactions. Azure offers specialized services. Azure Synapse Analytics, a unified analytics service that brings together data warehousing, big data analytics, and data integration. Azure Databricks, a fast, easy, and collaborative Apache Spark-based analytics platform for data science and machine learning. These services are built for different purposes than the transactional databases discussed above. They are optimized for complex, analytical queries over vast datasets, usually for reporting and insights, not for individual record lookups. 6.5 Choosing the right Azure database. Deciding which Azure database service to use depends on several factors. Data structure, highly structured and relational. Azure SQL Database, Azure Database for MySQL/Postgre, SQL/MariaDB. Unstructured, semi-structured, and flexible. Azure Cosmos DB, document, key value graph, scalability needs. Vertical scaling, more powerful server, relational databases. Horizontal scaling, more servers, NoSQL databases, especially Azure Cosmos DB. Global distribution requirements. If your application needs to be globally distributed with low latency, Azure Cosmos DB is unmatched. Existing expertise. If your team is proficient in SQL Server, Azure SQL Database is a natural fit. If they are familiar with MongoDB or PostgreSQL, those managed services are excellent choices. Cost model. Consider query patterns, data volume, and performance needs. 6.6 Security and backup basics for Azure databases. All Azure managed database services automatically handle routine tasks like backups, ensuring your data is protected. They also come with robust security features, including encryption. Data is encrypted at rest and in transit. Network security. integration with Azure virtual networks and firewalls to control access, authentication and authorization, integration with Azure Active Directory for user identity and role-based access control, threat detection, advanced features to detect anomalies and potential threats. Chapter 6 Summary. Databases are the digital memory of your applications, and Azure provides a comprehensive suite of managed services to meet every need. Whether your data is neatly organized in tables for traditional business applications, via Azure SQL Database or the open-source options, or requires the flexible, globally scalable power of a NoSQL solution like Azure Cosmos DB, Azure takes away the administrative burden. By delegating database management to Microsoft, your teams can focus on building innovative applications and extracting valuable insights from your data. With our applications having a place to run, compute, and a place to store data, storage, and databases, the next step is to make these applications smarter using the power of artificial intelligence and machine learning. Chapter 7. Building Smarter. AI, Machine Learning, and Cognitive Services in Azure. Artificial intelligence, AI, and machine learning, ML, have captured the world's imagination. From virtual assistants that answer your questions to recommendation engines that suggest your next favorite movie, AI is no longer science fiction. It's an integral part of our daily lives and a transformative force in business. For many, however, the concepts of AI and ML can feel abstract, complex, and out of reach. Azure aims to change that. Microsoft has heavily invested in making powerful AI and ML capabilities accessible to developers and businesses of all sizes, regardless of their deep data science expertise. This chapter will break down these concepts and introduce you to Azure's key services for building smarter applications, from pre-built AI building blocks to platforms for custom model development. 7.1 Introduction to AI, ML, and Cognitive Services. Let's clarify some common terms. Artificial intelligence, AI, a broad field of computer science that aims to create machines that can perform tasks that typically require human intelligence. This includes learning, problem-solving, perception, and decision-making. Machine learning, ML, a subset of AI where systems learn from data to identify patterns and make predictions or decisions without being explicitly programmed. Instead of writing rules for every possible scenario, you feed an algorithm a massive amount of data, and it learns the rules itself. Cognitive services. Think of these as prepackaged, ready-to-use AI capabilities that you can easily integrate into your applications using simple API calls. They allow you to add human-like intelligence such as seeing, hearing, speaking, and understanding without needing any deep ML expertise. Azure offers services that span the spectrum, from high-level cognitive services that require minimal AI knowledge to comprehensive platforms like Azure Machine Learning for experienced data scientists. 7.2 Azure Cognitive Services. AI for everyone. Concept. Azure Cognitive Services are a collection of cloud-based APIs, application programming interfaces, that enable developers to inject intelligent capabilities into their applications without needing to be AI or data science experts. These are pre-trained, pre-built AI models that Microsoft has developed and made available. You simply call the API, send data like an image or text, and receive an intelligent response. Analogy. Imagine you need to translate some text. You don't need to build a translation team or learn a new language yourself. You just use a translation app. Azure Cognitive Services are like those apps, but for specific AI tasks. You don't build the AI model, you just use Microsoft's ready-made ones. Let's look at some key categories and examples of what they can do. Vision enables applications to see and interpret images and videos. Examples. Identifying objects in an image, e.g., this image contains a car, a tree, and a dog. Recognizing faces and emotions, extracting text from images, optical character recognition, OCR, moderating content for adult or offensive material. Use case, an e-commerce platform could use vision services to automatically tag uploaded product images with relevant keywords, making them more searchable. Speech adds natural speech capabilities to applications. Examples. Speech-to-text, transcribing audio into written text, text-to-speech, converting written text into natural-sounding speech, speaker recognition, identifying who is speaking. Use case. A call center could use speech-to-text to transcribe customer service calls, then feed the text into other AI services for sentiment analysis. Language allows applications to understand and process natural language. Examples: text analytics, identifying key phrases, entities like people or organizations, and overall sentiment in text, positive, negative, neutral, natural language understanding, NLU. Understanding the intent behind a user's query for chatbots. Translator, real-time translation of text. Use case. A customer feedback system could use language services to analyze thousands of customer reviews, quickly identifying common complaints or positive sentiments, and even prioritizing urgent issues. For instance, if a company received thousands of written customer support requests, an Azure Cognitive Service could automatically categorize them, extract keywords like broken or refund, and even flag those expressing extreme frustration, allowing the support team to prioritize efficiently. Decision helps applications make intelligent decisions based on data. Examples: anomaly detector, identifying unusual patterns in data that might indicate problems. Content moderator, automatically filtering out objectionable text and images. Use case: a security monitoring system could use anomaly detector to flag unusual login patterns that might indicate a breach attempt. Azure Cognitive Services democratizes AI, making it accessible even to developers without a strong background in data science or machine learning. You simply integrate these services via their APIs, letting Microsoft handle the complexities of the underlying AI models. 7.3 Azure Machine Learning for data scientists and advanced ML. Concept: while cognitive services provide ready-to-use AI, Azure Machine Learning, Azure ML, is a cloud-based platform designed for data scientists and ML engineers to build, train, deploy, and manage custom machine learning models at scale. It provides a comprehensive set of tools and services for the entire machine learning lifecycle, from data preparation to model deployment and monitoring. Key capabilities: experiment tracking. Keep track of different model versions, parameters, and performance metrics. Model management. Register, version, and manage your trained models. Automated ML, AutoML, helps automate the process of selecting the best algorithm and tuning its parameters for a given dataset, often used by less experienced ML practitioners. ML Ops, machine learning operations, provides tools and processes for continuous integration, delivery, and deployment of ML models, akin to DevOps for software. Compute power provides scalable compute resources, virtual machines, GPU-enabled clusters for training large, complex models. Use cases: predictive analytics, forecasting sales, predicting customer churn, predicting equipment failure. Recommendation engines, building personalized product recommendations for e-commerce or content suggestions for streaming services. Fraud detection, developing models to identify suspicious transactions in financial systems. Custom image recognition, training models to recognize very specific objects or patterns unique to a business, e.g., identifying defects in manufactured goods. For instance, a large retail chain uses Azure Machine Learning to predict future demand for various products. By analyzing historical sales data, promotional calendars, and even local weather patterns, their data scientists train sophisticated models that help optimize inventory levels, reduce waste, and ensure products are always in stock when customers want them. This level of customization and control is possible with Azure ML 7.4, empowering business with AI and ML. Integrating AI and ML into your operations can drive significant business value. Personalized customer experiences, tailored recommendations, intelligent chatbots, and customized marketing messages. Automating mundane tasks, freeing up human employees to focus on more complex creative work. Gaining deeper business insights, discovering hidden patterns and trends in vast amounts of data that human analysts might miss. Improving decision-making, providing data-driven insights and predictions to support better strategic and operational decisions. Innovation, creating entirely new products and services that were previously impossible. 7.5 Responsible AI Principles, briefly. As AI becomes more powerful and pervasive, it's crucial to acknowledge the ethical considerations. Microsoft is a proponent of responsible AI, an approach to developing and deploying AI systems in a fair, reliable, safe, transparent, and accountable manner. Key principles include fairness. AI systems should treat everyone equitably. Reliability and safety. AI should perform reliably and safely. Privacy and security. AI systems should respect data privacy and be secure. Inclusiveness. AI should empower and engage all people. Transparency. AI systems should be understandable and their decisions explainable where possible. Accountability. People should be accountable for AI systems and their impact. These principles guide Microsoft's own AI development and are increasingly important for any organization deploying AI solutions. Chapter 7 Summary. Azure empowers businesses to build smarter applications by making artificial intelligence and machine learning accessible at various levels of expertise. From the ready-to-use, powerful capabilities of Azure Cognitive Services that allow rapid integration of human-like intelligence, to the comprehensive Azure Machine Learning platform that enables data scientists to build, train, and deploy highly customized AI models, Azure provides the tools. Embracing AI and ML is no longer optional. It's a strategic imperative that can transform customer experiences, automate processes, derive deeper insights, and drive innovation across all industries. With the ability to build intelligent applications, the next step is to explore how to run parts of your applications without ever managing a server, diving into the serverless revolution. Chapter 8. The Serverless Revolution. Azure Functions and Logic Apps. Imagine writing a piece of code that responds to an event, like a new file appearing in a storage account or an incoming message on a website. And you never have to worry about provisioning a server for it, patching an operating system, or scaling it up to meet millions of demands. You just write your code, deploy it, and it runs. This seemingly magical approach is at the heart of serverless computing, and it's transforming how applications are built and deployed in the cloud. While the term serverless might sound like there are no servers involved, that's not quite right. It means you don't have to manage the servers. The cloud provider, in this case, Microsoft Azure, handles all the server infrastructure, scaling, and maintenance behind the scenes. You only pay for the exact compute time your code uses, down to the millisecond. This chapter will introduce you to Azure Functions and Azure Logic Apps, two core components of Azure's serverless ecosystem. 8.1 What is serverless computing? Less server, more code. Concept. Serverless computing is an execution model where the cloud provider dynamically manages the allocation and provisioning of servers. You write and deploy your code as functions, and Azure runs that code only when it's needed in response to specific triggers or events. Analogy. Think of it like this. Traditional on-premises, you own the server. You build and run your own power plant to get electricity. High upfront cost, constant maintenance, and you pay even when no one is using power. Virtual machines, IaaS. You subscribe to a power utility, but you still have to manage a generator on your property. You pay for the generator being available even if it's idle. PaaS, like Azure App Service. You plug directly into the grid, and the utility provides the power, maintaining all the infrastructure. You pay for the capacity you've reserved, even if your usage fluctuates. Serverless, like Azure Functions. You plug into the grid, and you are only billed for the exact amount of electricity you consume when you actually switch on a light or run an appliance. You don't pay anything when your lights are off. Benefits of serverless computing. No server management, the most significant benefit. You don't provision, scale, or patch servers. Azure handles it all. This frees your developers and operations teams to focus purely on application logic. Automatic scaling. Azure automatically scales your serverless functions from 0 to thousands or millions of instances within seconds to handle any incoming load, and then scales down when demand subsides. Pay-per-execution cost model. You are only billed for the actual compute time used by your functions, typically down to millisecond increments. If your code isn't running, you're not paying. This can lead to significant cost savings for intermittent or bursty workloads. Faster time to market. With less infrastructure to manage, development cycles can be much faster, allowing you to innovate and deploy features more rapidly. Misconception. Remember, serverless does not mean no servers. It simply means less server management for you. Servers are still running behind the scenes, they're just entirely managed by Microsoft. 8.2 Azure Functions. Event-driven code execution. Concept. Azure Functions is the core serverless compute service in Azure. It allows you to run small pieces of code written in various languages. See Hash, Java, JavaScript, Python, PowerShell, TypeScript, in response to events, without having to explicitly provision or manage the underlying servers. How it works: trigger. An event occurs, e.g., an HTTP request, a new message in a queue, a file uploaded to blob storage, a database change, a scheduled time. Function execution. Azure automatically allocates compute resources and runs your function code in response to that trigger. Paper execution. You are billed only for the resources consumed during the execution of your function. Key features. Multiple languages. Develop functions in the language you prefer. Integrated with Azure services, functions can easily interact with data in Azure Storage, Azure Cosmos DB, Azure Event Hubs, and many other services. Bindings. Built-in bindings simplify connecting your function code to other services, reducing boilerplate code. Use cases. Real-time file processing. An e-commerce site might use a function to automatically resize and watermark images whenever a new product image is uploaded to Azure Blob Storage. Data transformation. Processing data streams from IoT devices, cleaning it, and loading it into a database. API endpoints. Creating lightweight REST-TFL APIs for web or mobile applications. Responding to database changes. Triggering a notification or an audit log entry when a new record is added to a database. Scheduled tasks. Running daily, weekly, or monthly reports or maintenance tasks, e.g., cleaning up old log files. Consider a startup building a mobile photo album application. When a user uploads a new high-resolution photo, it would be extremely inefficient to have a dedicated server constantly waiting to process it. Instead, they use an Azure function. When a new image lands in Azure Blob Storage, it triggers a function that automatically crops, resizes, and compresses the image for mobile viewing, and then stores the optimized versions back in storage, all within milliseconds, and they only pay for the few seconds of compute time actually consumed. 8.3 Azure Logic Apps. Orchestrating workflows visually. Concept. While Azure functions are excellent for running individual pieces of code, sometimes you need to orchestrate a sequence of actions, integrate multiple systems, or automate complex business processes across different services. This is where Azure Logic Apps shine. Logic Apps is a platform as a service (PaaS) that allows you to create automated, scalable workflows that integrate apps, data, services, and systems across enterprises or organizations. The key difference from functions is that Logic Apps are primarily visual and configuration-based rather than code-based. You design workflows using a drag-and-drop interface, connecting various pre-built connectors. Key features: hundreds of connectors. Connectors for virtually any service. Azure services, storage, Cosmos DB, functions, SaaS applications, Salesforce, Microsoft 365, MailChimp, Twitter, and even on-premises systems. Visual Designer. Build complex workflows by dragging and dropping actions and setting up conditional logic. Triggers and actions. Start a workflow with a trigger, e.g., new email in an inbox, item added to a database, and perform a sequence of actions. Use cases. Integrating SaaS applications. Automatically copying new leads from Salesforce to your CRM or new support tickets from a ticketing system to a Slack channel. Automated business processes. Automatically processing invoices, approving expense reports, or onboarding employees by connecting different IT systems. Monitoring and notifications. Sending an SMS alert if a server health check fails, or posting a message to Teams Slack when a critical event occurs in Azure. Data synchronization. Moving data between different databases or storage systems. Analogy. If an Azure function is a single, highly specialized machine that performs one task perfectly when a button is pressed, an Azure Logic app is like an elaborate Rube Goldberg machine or a complex factory assembly line. It connects many different machines and processes, connectors and actions in a predefined sequence, triggered by an initial event. For example, a marketing department wants to be notified every time their company is mentioned on social media. They can set up an Azure Logic app that uses a Twitter connector to trigger when a specific hashtag is mentioned. The Logic app then uses an Azure Cognitive Service from Chapter 7 to analyze the sentiment of the tweet. If the sentiment is negative, it sends an alert to a Microsoft Teams channel and creates a new ticket in their customer support system. All this without writing a single line of code. 8.4 Workflows and Business Agility with Serverless. Both Azure Functions and Logic apps enable significant business agility. They allow organizations to rapidly prototype and iterate, quickly build and test new ideas and integrations without the overhead of heavy infrastructure. Focus on business value. Developers focus on what makes their application unique, rather than spending time on server configuration. Respond to events in real time. Build reactive systems that respond immediately to changes and events. This agility can be a game changer for businesses looking to innovate faster and respond to market demands. 8.5 When to choose functions versus Logic apps. Choosing between Azure Functions and Logic apps often depends on your primary need. Choose Azure Functions when you need to execute custom code for specific, event-driven tasks. You require fine-grained control over the code logic. Your primary need is compute power that scales on demand. You're comfortable with writing code. Choose Azure Logic apps when you need to orchestrate a sequence of actions or automate a business process. You need to integrate multiple services, SaaS, Azure, on-premises. You prefer a visual, low-code, no-code approach to building workflows. The problem is more about integration than complex custom compute. It's also common to use them together. An Azure Logic app might trigger an Azure function to perform a complex calculation or data transformation that isn't easily done with standard connectors. And then the Logic app continues the workflow based on the function's output. Chapter 8 Summary. The serverless revolution in Azure, spearheaded by Azure Functions and Azure Logic apps, offers a transformative approach to application development. By eliminating the need for server management and embracing a pay-per execution model, these services empower businesses to build highly scalable, cost-effective, and agile applications. Whether it's running a small piece of event-driven code with Azure Functions or orchestrating complex multi-service workflows with Azure Logic apps, you're embracing the future of cloud computing, focusing on your application's logic and value, while letting Azure handle the operational heavy lifting. Now that we've explored building and running your applications, it's time to delve into the critical aspect of securing them in the cloud. Chapter 9, The Fortress in the Cloud. Securing your assets with Azure Identity and Security. In the digital age, security is paramount. A single data breach can devastate a company's reputation, financial standing, and customer trust. When you move your applications and data to the cloud, the conversation around security shifts, but its importance only grows. While cloud providers like Microsoft invest billions in securing their global infrastructure, you, the user, still play a crucial role in protecting your assets in the cloud. This chapter will delve into the critical aspects of security within Azure, focusing on identity management, access control, and robust security tools. We'll explore how Azure helps you build a strong defense around your valuable data and applications, turning your cloud environment into a fortress. 9.1 The Shared Responsibility Model Revisited. Before diving into specific services, it's essential to reiterate the shared responsibility model. This model clarifies what the cloud provider, Microsoft, is responsible for and what you, the customer, are responsible for. Microsoft's responsibility, security of the cloud. Microsoft is responsible for the physical security of data centers, the underlying network, host infrastructure, and basic virtualization. For PaaS and SaaS offerings, Microsoft takes on even more responsibility, managing operating systems, middleware, and applications. Your responsibility, security in the cloud. You are responsible for the data you put in the cloud, access controls, network configurations for your resources, operating system configurations for IaaS, applications, and identity management. For SaaS, your responsibility is largely limited to data, users, and device security. Think of it like this. Microsoft provides a secure building, the cloud infrastructure, locks the doors, and ensures the lights stay on. You are responsible for what you put inside your rented office space, who you give keys to, and how you secure your own filing cabinets and computers within that office. Understanding this shared model is fundamental to building a secure cloud strategy. 9.2 Azure Active Directory, Azure AD, your cloud identity hub. Concept: Azure Active Directory, Azure AD, is Microsoft's cloud-based identity and access management service. It's not just a cloud version of the traditional Windows Server Active Directory. It's a comprehensive directory service designed for managing users and groups and securing access to both cloud applications, like Microsoft 365, Salesforce, Box, and Azure resources. Key features: single sign-on, SSO. Users can sign in once with a single set of credentials and access multiple applications across the cloud and on-premises. This reduces password fatigue and improves security by making it easier to manage credentials. Multi-factor authentication, MFA, adds an extra layer of security by requiring users to provide 2 or more verification factors to gain access, e.g., something you know like a password, plus something you have like a phone or fingerprint. MFA is one of the most effective ways to prevent unauthorized access. Conditional access allows you to enforce policies based on various conditions, such as user location, device compliance, or sign-in risk. For example, you can require MFA only when users are signing in from outside the corporate network. Identity protection detects potential vulnerabilities affecting your organization's identities, e.g., leaked credentials, suspicious sign-ins, and provides automated responses. Hybrid identity seamlessly integrates with on-premises Active Directory through Azure AD Connect, allowing organizations to manage identities across both environments. Analogy: Azure AD is the bouncer, ID checker, and keymaster for all your cloud resources and applications. It verifies who you are, what you're allowed to access, and ensures you're doing so securely. Imagine a company that suffered a phishing attempt. An employee inadvertently clicked on a malicious link and entered their login credentials. However, because the company had enforced multi-factor authentication through Azure AD, the hacker couldn't gain access, even with the compromised password. The second factor, the employee's phone, wasn't available to the attacker, preventing what could have been a devastating breach. 9.3 Role-Based Access Control, RBAC, who can do what? Concept. While Azure AD manages who you are, Role-Based Access Control, RBAC, manages what you can do with what you have access to. RBAC provides fine-grained access management for Azure resources. It allows you to assign specific permissions to users, groups, or service principals, identities used by applications for a particular scope. How RBAC works: you assign a role to a security principal at a specific scope. Security principal: the who or what, a user, group, or application. Role: the what you can do, a collection of permissions. Azure provides many built-in roles, e.g., owner, contributor, reader, user access administrator. You can also create custom roles. Owner has full access to manage all resources, including delegating access to others. Contributor can create and manage all types of Azure resources but cannot grant access to others. Reader can only view existing Azure resources. Scope: the where or what level management group for large organizations, subscription, resource group, or individual resource. Permissions inherited down the hierarchy. Benefit: RBAC enforces the principle of least privilege, meaning users should only have the minimum permissions necessary to perform their jobs. This significantly reduces the risk of accidental misconfigurations or malicious activity. Analogy: if your Azure subscription is a building, and Azure AD controls who gets past the front door, then RBAC manages what each person can do inside the building. A janitor reader role can see all the rooms but not alter anything. An accountant contributor role can create and modify financial records but not hire new staff. And the CEO owner role has ultimate power to do anything and delegate responsibilities. 9.4 Microsoft Defender for Cloud, formerly Azure Security Center, your unified security dashboard. Concept: Microsoft Defender for Cloud is a unified infrastructure security management system that strengthens the security posture of your cloud and hybrid environments. It helps you prevent threats, detect them, and respond to them. It acts as your central security hub. Key capabilities: security posture management, provides recommendations to improve your security posture through the Secure Score, a quantifiable measure of your security health. Threat protection, detects and alerts you to potential security threats across your Azure resources, VMS, storage, SQL databases, app services. Regulatory compliance, helps you assess and improve your compliance with security benchmarks like PCI DSS, ISO 27001, and HIPAA. Security alerts, provides prioritized alerts with actionable insights to remediate detected threats. Defender for Cloud is continuously monitoring your Azure environment, automatically scanning for vulnerabilities, and providing security best practices, taking a proactive approach to security. 9.5 Azure Key Vault, protecting your secrets. Concept: in modern applications, there's often a need to store sensitive information like database connection strings, API keys, encryption keys, and digital certificates. Storing these secrets directly in application code or configuration files is highly insecure. Azure Key Vault provides a secure, centralized store for these secrets. Benefit: enhanced security. Secrets are stored in a hardware security module, HSM, backed solution, providing a high level of protection. Centralized management, simplify the management and rotation of secrets across your applications. Reduced risk, prevent secrets from being hard-coded or exposed in less secure locations. Applications can securely retrieve secrets from Key Vault at runtime without exposing them to developers or storing them in version control systems. 9.6 Network Security Best Practices Recap. While covered in Chapter 5, it's worth reiterating the critical role of network security. Network security groups, NSGs, your fundamental firewall in the cloud, controlling traffic flow to and from your resources. Always apply the principle of least privilege, only opening ports that are absolutely necessary. Azure VNet Isolation, running resources in private virtual networks, not directly exposed to the internet. Azure Firewall, a managed cloud-native network security service that protects your Azure virtual network resources. It provides high availability, scalability, and advanced threat protection. Azure DDoS Protection protects your Azure resources from distributed denial of service, DDoS, attacks, which attempt to overwhelm a service with immense traffic. 9.7 Compliance and Governance, meeting regulatory needs. Azure's immense scale comes with the responsibility of meeting global regulatory and industry-specific compliance requirements. Microsoft ensures Azure adheres to a vast array of global, national, and industry-specific compliance standards, e.g., HIPAA for healthcare, GDPR for data privacy, FedRAMP for U.S. government. This helps organizations meet their own compliance obligations when using Azure. Azure Policy, a service that helps you enforce organizational standards and assess compliance at scale. You can create policies to ensure that resources are deployed in approved regions, adhere to naming conventions, or have specific security settings configured. A healthcare provider, for example, is bound by strict regional and international patient data privacy regulations. By leveraging Azure's certified compliant infrastructure, coupled with rigorous RBAC access controls, encryption, and audit trails provided by Azure Monitor, discussed in Chapter 10, they can confidently store and process patient data in the cloud while adhering to all necessary regulatory requirements like HIPAA. Chapter 9 Summary. Security is not an afterthought in Azure. It's deeply integrated into the platform's core. By leveraging services like Azure Active Directory for identity and access management, implementing fine-grained role-based access control, and adopting proactive security solutions like Microsoft Defender for Cloud and Azure Key Vault, you can build a resilient and secure cloud environment. Understanding and actively managing your responsibilities within the shared responsibility model is crucial. With your assets now secured like a fortress, the next chapter will focus on how to keep tabs on your cloud environment, ensuring performance, identifying issues, and managing costs efficiently. Chapter 10: Keeping Tabs, Monitoring, Management, and Cost Optimization in Azure. Building and deploying applications in the cloud is exciting, but the journey doesn't end there. Once your resources are running, the real work of monitoring, managing, and optimizing them begins. Without proper oversight, applications can suffer performance issues, costs can spiral out of control, and security vulnerabilities can go unnoticed. This chapter will introduce you to the essential tools and strategies Azure provides to keep a watchful eye on your cloud environment. Ensure everything runs smoothly, identify and fix problems, and, crucially, manage your spending. Think of these tools as your mission control center, providing you with real-time telemetry and actionable insights into your cloud operations. 10.1 Introduction: Managing your cloud estate. In the agile, dynamic world of cloud computing, continuous management is key. Unlike traditional fixed IT infrastructure, cloud resources can scale up and down rapidly, generating vast amounts of data about their performance and usage. Effective management is built on 4 core pillars: monitoring, collecting and analyzing data about resource performance, health, and availability; logging, capturing detailed records of events, operations, and activities within your environment; cost management, understanding, controlling, and optimizing your Azure spending; automation, using tools and scripts to simplify routine tasks and enforce policies. 10.2 Azure Monitor: Your eyes and ears in the cloud. Concept: Azure Monitor is a comprehensive solution for collecting, analyzing, and acting on telemetry data from your Azure, other cloud, and on-premises environments. It provides a unified view of the performance and health of your entire ecosystem. Key features: metrics. These are numerical values that describe some aspect of a system at a particular point in time. Examples include CPU utilization, network I/O, disk read-write operations, and database query durations. Metrics are often used for real-time monitoring and alerting. Logs. These are event and performance data collected from various sources, like application logs, diagnostic logs from Azure services, and activity logs. Logs are typically used for historical analysis, troubleshooting, and auditing. Azure collects these logs into log analytics workspaces, where you can query them using a powerful language called Kusto Query Language, KQL. Alerts. You can set up alerts to proactively notify you when specific conditions are met. For example, an alert could fire if a VMS CPU usage exceeds 90% for 5 minutes, or if the number of errors on your web application suddenly spikes. Alerts can trigger emails, SMS messages, push notifications to mobile apps, or even automated actions, like scaling out resources. Dashboards. Azure Monitor allows you to create custom dashboards that visualize key metrics and log data in a single pane. This gives you an at-a-glance view of your environment's health and performance. Use cases: performance troubleshooting, quickly diagnose why an application is slow. Proactive issue identification, catch problems before they impact users. Capacity planning, understand resource utilization trends to plan for future needs. Auditing and compliance, review who did what and when in your Azure environment. Analogy. Azure Monitor is like a sophisticated control tower for an entire airport. It doesn't just watch one plane, it monitors every plane resource, every radar signal metric, every communication log, and every weather update alert, providing a comprehensive, real-time picture of the entire operation, allowing controllers to respond proactively to any issue. 10.3 Azure Log Analytics. Deep dive into your data. While Azure Monitor is the umbrella service, Log Analytics is the specific service within it that stores and enables querying of your log data. You configure various Azure resources, and even non-Azure sources, to send their diagnostic and operational logs to a Log Analytics workspace. Within the workspace, All this data is consolidated, allowing you to run complex queries across different data sources. For example, you could query to see all log entries from a particular virtual machine that occurred around the same time as a database error, helping to correlate events and pinpoint root causes. The ability to centralize and query logs is invaluable for debugging, security analysis, and understanding user behavior. 10.4 Azure Cost Management plus Billing. Staying within budget. One of the most appealing aspects of cloud computing is the pay-as-you-go model. But without proper management, it can also lead to unexpected expenses. Azure Cost Management plus Billing provides the tools you need to gain visibility into your spending, control costs, and optimize your cloud investment. Key features: cost analysis. Visualize your spending in various ways by subscription, resource group, individual resource, service type, or custom tags. This helps you understand where your money is going. Budgets. Set spending limits for your subscriptions or resource groups and receive email alerts when you approach or exceed your defined thresholds. This is a crucial control mechanism. Cost optimization recommendations. Azure provides AI-driven recommendations to help you save money. These might suggest resizing underutilized virtual machines, deleting idle resources, or migrating to more cost-effective service tiers. Cost export. Automate the export of your detailed cost data to Azure Storage or other systems for deeper analysis or integration with internal financial systems. Analogy. Azure Cost Management is like a sophisticated personal finance app for your cloud spending. It categorizes your expenses, lets you set budgets and alerts, and even suggests ways to cut down on unnecessary spending. Consider a software development team that was working on a new project. They were deploying several high-powered virtual machines for testing, often leaving them running overnight. Using Azure Cost Management, their manager noticed a significant spike in costs. By reviewing the cost analysis, they identified the always-on VMs. Implementing a policy to automatically shut down development VMS after business hours resulted in a 40% reduction in their monthly bill for that project without impacting productivity. 10.5 Strategies for Cost Optimization. Beyond the tools, here are some practical strategies for managing and optimizing your Azure costs. Right sizing. Ensure your resources, e.g. VMS, app service plans, are appropriately sized for their workload. Don't pay for more compute or storage than you actually need. Deleting unused resources. This is the easiest and most impactful way to save money. If you're not using a resource, VM, storage account, database, delete it. Reserved instances, RIs. If you have predictable, steady-state workloads, e.g., a production VM that runs 24/7, you can commit to a 1-year or 3-year reservation. This provides significant discounts, often 40 to 70%, compared to pay-as-you-go rates. Azure Hybrid Benefit. If you have existing Windows Server or SQL Server licenses with software assurance, you can bring them to Azure, greatly reducing the cost of running those workloads in the cloud. Pausing deallocating resources. For resources like virtual machines that aren't needed 24/7, you can deallocate them. When a VM is deallocated, you only pay for storage, not compute, which can lead to substantial savings. Leveraging cheaper storage tiers. As we learned in Chapter 4, use the appropriate blob storage access tier, cool, or archive for infrequently accessed data. Embracing serverless. For intermittent or event-driven workloads, Azure Functions and Logic Apps, Chapter 8, offer a highly cost-effective model where you pay only when your code runs. 10.6 Automation with Azure Automation and Azure DevOps, brief mention. To make management and cost optimization more efficient, automation is key. Azure Automation allows you to automate routine, repeatable tasks, e.g., automatically stopping VMS on a schedule, running PowerShell or Python scripts for maintenance. Azure DevOps provides a suite of tools for collaborative software development, including continuous integration, continuous deployment, CI/CD pipelines, which can automate the deployment of new resources and applications, ensuring consistent configurations. Infrastructure as Code, ISC. Using tools like Azure Resource Manager, ARM, templates, Bicep, or Terraform to define and deploy your entire Azure infrastructure through code. This ensures consistency, reproducibility, and version control for your environment. Chapter 10, Summary. Effective monitoring, management, and cost optimization are vital for a successful cloud strategy. Azure provides powerful, integrated tools like Azure Monitor for comprehensive observability and Azure Cost Management plus billing for financial control. By actively utilizing these services and adopting smart strategies like right-sizing, leveraging reservations, and automating tasks, you can ensure your Azure environment performs optimally, remains secure, and stays within budget. With a deep understanding of Azure's capabilities and how to manage them, it's time to look at how real-world businesses are transforming their operations using Azure, which will be the focus of our next chapter. Chapter 11. Real-World Azure, Case Studies and Practical Applications. We've journeyed through the foundational concepts of cloud computing, navigated the Azure portal, and explored a wide array of Azure services. From compute and storage to databases, AI, serverless, security, and management. Now, it's time to bring these pieces together and see how real organizations, from startups to large enterprises, are leveraging Microsoft Azure to solve complex business challenges, innovate, and gain a competitive edge. This chapter presents diverse case studies that illustrate the tangible benefits and practical applications of Azure across various industries. These examples will demonstrate how the services we've discussed translate into real-world solutions that drive digital transformation and deliver concrete results. 11.1 The Power of Cloud in Action. Diverse use cases. Azure's flexibility makes it suitable for almost any industry and business size. The case studies below highlight a range of scenarios, from handling massive online traffic to deriving insights from complex data and modernizing legacy IT. Each demonstrates how Azure's integrated services create powerful, tailor-made solutions. 11.2 Case Study 1. E-commerce scalability, retail sector. The problem: a leading online fashion retailer experienced recurring website outages and slow performance during seasonal demand spikes, particularly during major sales events like Black Friday. Their on-premises infrastructure couldn't scale quickly enough to handle the sudden surge in customer traffic, leading to lost sales and customer frustration. The Azure solution. The retailer migrated their entire e-commerce platform to Azure, leveraging several key services. Azure App Service hosted their primary web application, taking advantage of its auto-scaling capabilities to automatically add more web server instances when traffic surged and scale back down during quieter periods. Azure SQL Database, used for their product catalog, customer orders, and transaction data, benefiting from its high availability, automatic backups, and intelligent performance tuning. Azure Blob Storage stored all product images, videos, and customer-uploaded content, leveraging its massive scalability and cost-effective access tiers. Azure CDN, Content Delivery Network, distributed static content images, JavaScript, CSS, globally, ensuring that customers received content from the nearest geolocation, significantly improving page load times. Azure Monitor, Chapter 10, provided real-time visibility into website performance and automatically alerted the team to potential issues. The outcome: the retailer successfully handled unprecedented traffic volumes during their busiest sales period without a single outage or slowdown. Conversion rates improved significantly due to a smooth user experience. Operational costs were optimized because they only paid for the extra compute and network capacity during peak times, rather than maintaining expensive, idle servers year-round. Azure enabled them to transform a vulnerability into a competitive advantage. 11.3 Case Study 2. Data Analytics for Business Insight, Manufacturing Logistics. The problem: a large manufacturing company had vast amounts of operational data scattered across various systems, sensor data from factory equipment, supply chain logistics, customer orders, and sales figures. They struggled to consolidate this disparate data and derive meaningful insights to optimize production, predict maintenance needs, and improve their supply chain. The Azure solution. The company built a comprehensive data analytics platform on Azure. Azure IoT Hub ingested real-time telemetry data from thousands of factory machines and sensors, Chapter 3. Azure Data Lake Storage served as a centralized, scalable repository for all raw and processed data, supporting massive volumes of diverse data types. Chapter 4. Azure Databricks and Azure Synapse Analytics used for processing, transforming, and analyzing the big data at scale, combining data warehousing with big data processing capabilities. Chapter 6 and 7. Azure Machine Learning. Chapter 7. Developed predictive models to forecast machine failures based on sensor data, enabling proactive maintenance. They also built models for demand forecasting and supply chain optimization. Power BI provided interactive dashboards and reports, allowing business users to visualize insights and make data-driven decisions without deep technical knowledge. The outcome: the company achieved significant improvements, including a 15% reduction in equipment downtime due to predictive maintenance, optimized inventory levels, and a more resilient supply chain. These insights led to substantial cost savings and improved operational efficiency. Their data became a strategic asset, driving better decision-making across the organization. 11.4 Case Study 3. Modernizing an enterprise application, financial services. The problem: a long-standing financial institution relied on a critical, bespoke customer relationship management (CRM) application running on aging servers in their on-premises data center. The application was difficult and costly to maintain, slow to innovate, and posed increasing security and compliance risks. The Azure solution: the institution embarked on a phased migration and modernization journey. Azure Virtual Machines. Initially, they lifted and shifted the core CRM application components to Azure VMS to immediately alleviate the burden of physical hardware maintenance and gain scalability. Chapter 3. Azure SQL Managed Instance migrated their large SQL Server database to Azure SQL Managed Instance, gaining the benefits of a PaaS solution while maintaining high compatibility with their existing SQL Server code and tools. Chapter 6. Azure App Service gradually refactored and modernized certain front-end components and added new features using Azure App Service, allowing their development teams to build and deploy faster. Chapter 3. Azure Active Directory, Azure AD, and RBAC integrated the application's authentication with Azure AD for secure single sign-on and managed user access through role-based access control, ensuring compliance and robust security. Chapter 9. Azure Key Vault centralized the secure storage of their application's sensitive secrets, such as database connection strings and API keys. Chapter 9. The outcome: the financial institution significantly reduced its operational costs related to infrastructure and legacy software. The modernized application became more agile, allowing them to release new features to customers faster. Security posture was vastly improved, meeting stringent regulatory requirements through Azure's built-in controls and continuous monitoring. 11.5 Case Study 4. Enabling remote work and collaboration, professional services. The problem: a global consulting firm needed to provide its rapidly growing and geographically dispersed workforce with secure, high-performance access to specialized desktop applications and sensitive client data, regardless of their location or device. Traditional VPNs and on-premises virtual desktop infrastructure (VDI) were becoming bottlenecks. The Azure solution: the firm implemented a cloud-based virtual desktop solution using Azure. Azure Virtual Desktop (AVD) provided a comprehensive, scalable, and secure virtual desktop experience. Users could access their full Windows desktop and business applications from any device, laptop, tablet, phone, with an internet connection, ensuring a consistent and secure work environment. Azure Files hosted shared departmental and project files mounted directly within the virtual desktops, offering seamless collaboration. Chapter 4. Azure AD managed user identities and provided secure access with multi-factor authentication and conditional access policies. Chapter 9. Azure Networking utilized virtual networks and VPN gateways to securely connect their users to the AVD environment while maintaining privacy and regulatory compliance. Chapter 5. The outcome: The firm enabled effortless and secure remote work for thousands of employees worldwide. They significantly reduced hardware acquisition and maintenance costs by centralizing their desktop infrastructure. Productivity increased as consultants could work efficiently from any location, and data security was enhanced by keeping sensitive information off local devices. This allowed them to scale their operations faster and more flexibly than ever before. 11.6 other industry examples, brief mentions: healthcare, securely storing patient electronic health records, EHRs, performing medical image analysis with AI, and enabling telemedicine platforms with secure communication tools. Gaming, providing global scale and low-latency multiplayer experiences using Azure Cosmos DB, Chapter 6. Running dedicated game servers on VMS or containers, Chapter 3. And delivering game assets quickly via Azure CDN. Government, leveraging Azure government clouds for highly secure and compliant infrastructure, hosting citizen services applications, and processing public data. Chapter 11 Summary. These case studies vividly demonstrate that Azure is far more than just a collection of technical services. It's a powerful enabler of business transformation. By strategically combining Azure's compute, storage, database, AI, networking, and security capabilities, organizations are solving real-world problems, innovating faster, improving customer experiences, and achieving significant operational efficiencies. As you've seen, mastering Azure allows you to tackle complex challenges and embark on your own path of digital innovation. In our final chapter, we'll reflect on the ever-evolving nature of cloud computing and discuss how you can continue your Azure journey. Chapter 12, Beyond Today, exploring the future of Azure and your cloud journey. You've now journeyed through the extensive landscape of Microsoft Azure, from the fundamental concepts of cloud computing to the intricacies of its core services for compute, storage, databases, AI, serverless, networking, security, and management. You've seen how these services come together in real-world scenarios to deliver tangible business value. This final chapter isn't an endpoint, it's a launchpad. The cloud is not a static destination, but a dynamic, ever-evolving ecosystem. We'll look at the exciting directions Azure is heading, and more importantly, how you can continue your own learning and growth within this transformative field. 12.1 The ever-evolving cloud landscape. The cloud computing industry is characterized by relentless innovation. What was cutting edge last year might be standard practice today, and new capabilities are constantly emerging. Trends like edge computing, processing data closer to its source, e.g., IoT devices, factory floors, rather than sending it all to the cloud, reducing latency and bandwidth needs. Artificial intelligence, AI, everywhere. AI continues to deepen its integration into more services, enabling hyper-personalization, intelligent automation, and advanced analytics on an unprecedented scale. Quantum computing. While still in its early stages, quantum computing promises to revolutionize problem-solving for complex challenges currently beyond the reach of classical computers. Azure is at the forefront of providing tools and access to quantum hardware. Sustainability. Cloud providers are increasingly focusing on making their data centers and operations more environmentally friendly, leveraging renewable energy and optimizing resource consumption. Hyperconvergence and distributed cloud. Extending cloud capabilities directly to enterprise data centers, enabling a truly unified hybrid experience. 12.2 Azure's continuous innovation. Microsoft's commitment to innovation means Azure is perpetually expanding its capabilities and introducing new services. Some key areas of focus for Azure's future include further hybrid cloud integration. Tools like Azure Arc are making it even easier to manage servers, Kubernetes clusters, and data services across on-premises, multi-cloud, and edge environments, all from the Azure portal. This provides true consistency in management anywhere. AI at the edge. Bringing AI capabilities closer to where the data is generated, enabling real-time decision-making for scenarios like autonomous vehicles, smart factories, and remote healthcare. Serverless advancements. Continued expansion of serverless offerings, making it easier to build and deploy highly scalable, cost-effective applications for a wider range of workloads. Industry-specific clouds. Microsoft is developing tailored cloud solutions for specific industries, e.g., healthcare, financial services, retail that integrate industry data models, compliance frameworks, and business processes. Enhanced security and governance. As cyber threats evolve, Azure security services are continuously updated with advanced threat intelligence, automated response mechanisms, and comprehensive compliance tools. This continuous evolution means that the Azure you experience today will be even more powerful and versatile tomorrow. 12.3 The Cloud as a Career Accelerator. The rapid growth of cloud computing has created an unprecedented demand for cloud skills. Whether you're a developer, an IT professional, a data analyst, or a business leader, understanding cloud concepts and specific platforms like Azure is becoming increasingly vital. Developers need to understand how to build cloud-native applications, leverage PaaS and serverless services, and choose the right compute options. IT operations professionals transition from managing physical servers to managing cloud resources, optimizing costs, and ensuring cloud security and governance. Data scientists analysts utilize cloud big data and AI services to extract insights and build intelligent models at scale. Business leaders need to understand the strategic implications of cloud adoption, how it can drive innovation, reduce costs, and enable new business models. Learning Azure isn't just about gaining technical proficiency. It's about acquiring skills that are relevant across virtually every industry and role in the modern economy. 12.4 Next Steps for Your Azure Journey. This book has provided a foundational understanding of Azure. To truly master it, you must engage in continuous learning and hands-on practice. Here's how you can continue your Azure journey. Hands-on practice is crucial. Nothing solidifies learning like doing. Continue to use your Azure free account. Don't forget to manage costs. To deploy resources, experiment with services, and build small projects. Try to recreate some of the case studies or simply follow along with tutorials. Official documentation is your friend. The official Azure documentation, docs.microsoft.com/Azure, is incredibly comprehensive and constantly updated. It's the authoritative source for detailed information, tutorials, and best practices. Microsoft Learn. Microsoft offers Microsoft Learn, learn.microsoft.com, a fantastic, free, self-paced learning platform. It provides structured learning paths, modules, and hands-on exercises, often within a free sandbox environment, so you don't even need your own subscription. This is an excellent resource for deepening your knowledge. Join the community. Engage with the Azure community through online forums, e.g., Microsoft Q&A, Stack Overflow, user groups, and social media. Learning from others and sharing your experiences is invaluable. Explore certifications, optional but beneficial. While not a prerequisite for understanding, Azure certifications can validate your skills and boost your career. AZ900 Azure Fundamentals, a great entry-level certification that covers the core concepts discussed in this book. AZ104 Azure Administrator Associate, for those looking to manage Azure resources, networks, and identities. AZ204 Developing Solutions for Microsoft Azure, for developers building applications on Azure. There are many more advanced certifications for specific roles like security engineer, data scientist, or DevOps engineer. 12.5 The cloud's impact on business and society. Beyond the technical aspects, it's important to reflect on the profound impact cloud computing and Azure is having. Democratizing technology. Cloud services lower the barrier to entry for startups and small businesses, allowing them to access powerful, enterprise-grade technology that was once exclusive to large corporations. Accelerating innovation. By providing on-demand access to advanced services like AI, IoT, and high-performance computing, the cloud empowers researchers and developers to accelerate discoveries and bring innovative products to market faster. Driving sustainability. Cloud providers like Microsoft are leading the charge in sustainable computing, investing heavily in renewable energy, optimizing data center efficiency, and promoting green coding practices. By migrating to the cloud, organizations can often reduce their own carbon footprint, compared to maintaining on-premises data centers. 12.6 Final thoughts. Embracing the cloud mindset. The cloud is more than just a collection of technologies. It's a different way of thinking about IT infrastructure, resource consumption, cost management, and ultimately, innovation. It encourages agility, experimentation, and a focus on delivering business value rather than just keeping the lights on. Your journey into Azure is just beginning. Embrace the spirit of continuous learning, curiosity, and hands-on exploration. The cloud landscape will continue to evolve, and with the foundational knowledge you've gained from this book, you are well equipped to navigate its complexities and harness its immense power. The future is cloudy, and you are now ready to be a part of it.